Hi, in this video we are going to see about dynamic stabilization. What is dynamic stabilization? Dynamic stabilization in robot. The stabilization is that how the robots move or move to another places. An introduction to dynamic stability in robots. This presentation explores the dynamic stabilization concept in robots, focusing on how it enhances stability and performances. Right? Focusing on how it enhances stability and performances. We will develop into its application and benefits in various robot systems. Dynamic stabilization advanced algorithms to continuously adjust the robot's balance and posture in responses to the external forces. Okay, dynamic stabilization advances algorithms to continuously adjust the robot's balance and posture in response to external forces. This results in improved stability and agility. Improved stability and agility vital for complex tasks, which is very vital for complex tasks. Basically, what is dynamic stability? Stability is that the balancing or balancing a thing which is to be stand still, right? That is called stability. Whereas in robots we have robots or we have wheeled robots, legged robots or like that, right? The wheeled robots should have their stability to rotate in the rotate and to be stand still in their structure. For that we need a dynamic stability, right? Next, enhancing stability in robots. Dynamic stabilization plays a crucial role in enhancing stability by effectively countering disturbances and maintaining equilibrium. Okay, dynamic stability plays a crucial role in enhancing stability by effectively countering disturbances. Eventually the disturbances will be alarmed and the stability dynamic stability of the robot is maintained equally. Okay, enabling robots to perform tasks with precision and confidence, which helps in the robots to perform their tasks very well and to be very confident, right? The integration of dynamic stability significantly enhances performance by enabling robots to execute dynamic movement with greater accuracy and speed, leading to improved efficiency and productivity. As I told you, the continuous disturbances are intimated to the robot continuously. Since it is intimated continuously to the robot control structure, it can perform their tasks in a very speed, and accuracy will be very good and the efficiency will be very good. Even though when these three are very good, the productivity will be very good, right? Next, dynamic stability. A fundamental difference between locomotive mechanism is whether they are statical or dynamic stable. Whether they are statical or dynamically stable. A statically stable mechanism will not fall even when all its joints freezes. Okay, a dynamically stable robot instead requires constant motion to prevent it from falling. Okay, there is a difference between static stability and dynamic stability. In static stability, even though the joint of the robots gets freezed, it does not affect any stability in that. Okay, when dynamic stability requires any disturbances, the robots will be in trouble. So that we are going to identify how the dynamic stability to be maintained, right? Stable robots can overcome their problems by changing its configuration so rapidly that a fall is prevented. Dynamically, their configuration should be changed so that their fall can be prevented. An example of a purely dynamic stable robot is an inverted pendulum on a cart. Inverted pendulum on a cart. Such a robot has no statically stable configuration and needs to move all the time to keep the pendulum upright. Pendulum is that it always oscillates, right? Likewise, this dynamic stability has to be designed. While dynamic stability is desirable for high speed, agile motions, robots should be designed so that they can easily switch into the statically stable configuration. These dynamic stable configurations, stability of the robot to be designed in such a way that high speed, agile motion should be very good, and robots should be designed that can easily adapt to statically stable configurations also. Why? Because if the dynamic stability has some issues in that, it automatically changes to the stable robots, and it can work according to that, right? These are the concepts of dynamic stabilization.